Hello. In this lesson, I'm going to review conversion between scientific notation in standard form, recognizing scientific notation on your calculator TI-84. So this is to support the material for chapter 3. Right. So let's do the first objective. Convert between scientific notation and standard form. Now, this is our scientific notation here. And this is another scientific notation. Notice that for the first number here, have a positive integer here, positive exponent, a 12, meaning I have a number that's really big. With 1.54, I'm going to move the decimal to the right 12 times. Where notice a negative exponent here, meaning that for the 2.6, I can move it to the left 5 times, which is going to have a small number. There's a number between 0 and 1, which is this one's very small. Now, another scientific notation in the form of n times 10 to the k is always in that form, where k is an integer and the absolute value of n is between 1 and 10. So not including 10 here. So a number could be 9.9999, but not including 10, right? So that's a scientific notation. So let's try to convert between scientific notation and standard form. Now, the list here, the steps for you to follow to convert from one to the other. So we'll say in order to write scientific notation in the form of n times 10 to the k in standard decimal notation, we move the decimal point of number n by following. If k is positive, we multiply n by 10k times and move the decimal point k placed to the right. So k positive, I move it to the right k times. If k is negative, I divide the n by 10k, or I can move the decimal to the left k times. All right, let's do some example. Example 1, I'm going to convert 4.325 10 to the negative 4 to standard form. So first thing, let me write it down. I know that the number negative 4, meaning they're going to be a small number. Right? So 4.325. And I'm going to move to the left. Negative tells me divide by 10 to the k, or left 4 times. Just do left time, moving it. So I will have left 1, 2, 3, 4. Right? So let me write. That means my decimal is right here now. And in between, I can just fill in with 0. Right? So total here, I move to the left 4 times and I write 0 in the front. So my final answer is 0.123 right here, 4325. That will be standard decimal notation form. Okay, so now let's do example 2. I convert to standard decimal form. So again, 3.07, and notice that my power of 10 to the 8 power, meaning I'm going to have a really big number. So I'm going to write it the decimal first. 3.07, positive integer k is a, so I'm going to move to the right 8 times. So 2, 4, 6, 8. So my decimal number here, and I'm going to fill in with zeros. 2 here, 2 here, 2 here. So I have it moved 8 times. So revise my answer will be 307 with 6 zeros. 1, 2, 3, 1, 2, 3. Right. So that will be my final answer. Let's do some practice. Convert the scientific notation to standard form. Again, notice that exponent 5, meaning I move the decimal to the right 5 times. So I can write it out. Okay. 1.75, positive k equal to 5, positive, move the right 5 times. So I can do 1, 2, 3, 4, 5. So my decimals right here. Fill it in with 0. 3, 4, 5. Right. So I can rewrite it. So it's 175 with 3 zeros. So 175,000. Right. I can do the same thing. Negative k equal negative 9, meaning left 9 times. I move it to the left 9 times. So I have 1. Let me use a different color here. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9. So what that means, before 4, I'm going to put 8 zeros, right? That's what it means here. So I could say 0 point with 8 0 follow before the 4. So 1, 2, 3, 4, 1, 2, 3, 4. And then I would have the 4 will be the 9 one. So 4, 0, 6, 7. That will be my final answer. A very small number. In the second part here, we're going to convert from standard notation to scientific notation, the other direction. So let's do one. All right. So notice at my n, I'm going to write a number. The first number has to be the integer n times 10 to the k or negative k. So I'm going to multiply it. If it's can move to the right, I'm going to do negative k. If move to the left, I'll do positive k. So again, this is, think of in rule of thumb, think of it, if it's a small number, I'm going to have a negative exponent, negative k. So let's do it. So I have a decimal form here. I'm going to move it. So I'm going to move to a number between 1 and 10. So let's write it. So we 2, I move 4, 5 times. Notice that I move to the right 5 times. So therefore negative 5, which is my k. Right? K is negative 5. So I can rewrite this as 6.7 times 10 to the negative 5. Right? Let's do the next one. I'm going to write a scientific notation. Now this is a really big number. And right now my decimal is over here. Okay? So I'm going to move to the left. So 3, 6, 9, 12 times. So I'll move this direction here 12 times. So 12 times. So k is equal to positive 12. It's a big number. So I'm going to have 3.09 times 10 to the 12 power. And that will be my scientific notation. Right? So I would suggest you pause the video. Try these two problems over here. Hope that you've done it. So let's do it together. So again, right now my decimal is right here. I need to move to the left until I get a number that's between 1 and 10, not including 10. So 3, 6, 7. So I move 7 times. So my k is equal to 7. So I would have 6.7 times 10 to the 7th power. Okay, and try one more. 3, 6, 8 times. So k equal to negative 8 because I moved to the right 8 times. So therefore, I can write my answer as 5.6 times 10 to the negative 8. Whole problem here that makes practice. I would suggest you pause the video again and try it out. Okay, hope that you tried it. So now let's do it together. All right, so again, I'm going to move my decimals. So notice my decimals right here, I'm going to move it to the right. Let me use a different color. So 2, 4, 6, 8 times. So I move 8 times. So k equal to negative 8. Again, I'm moving to the right, so it's a negative exponent. And again, negative number tells me you have a small decimal number, which is correct. So we have 9.7 times 10 to the negative 8. Okay, I'm doing the same thing here. So next one here, my decimals right now is here. So I move to the left 3, 6, 9, 10 times. Right? So k equal to 10. So I can write my notation at 4.5 times 10 to the 10 power. Right? 3.4. Now I'm going to convert a scientific notation to standard form. To convert that, I can just write it 3.4, 10 to the 6th power. 6 is positive, I'll move to the right direction. 6 times, so 1, 2, 3, 4, 5, 6. So my decimals right here. I can fill it in with zeros. 5 0 total here. Okay. So my final answer is 3, 4 with 5 zeros. 1, 2, 3, 4, 5. Right. Next one, 8.23. Let me write it a little to the right so I can move it. So 8.23 times 10 to the negative 7. Again, negative 7. I'm going to move to the left to convert to standard form. So 1, 2, 3, 4, 5, 6, 7. These are my decimal, and I filled it in with 6 zeros. 1, 2, 3, 4, 5, 6. Right? So 0.123, 123 will be 823. That will be my final answer. So I'm going to highlight all my final answers. It's good practice, and that's what makes practice for conversion between scientific notation in standard form. Okay. Now, let's recognizing scientific notation on your calculator. Many times I'll see somebody tell me when we do probability in chapter 5 or later, you see 1.25, let's say to a negative 5 power, I think the probability is 1.25, which is not the case, right? In your calculator, you see that. Some say, oh, my answer is 1.25. Actually, that's not true. It means that 1.25 with a decimal, 10 times 10 to the negative 5 power. This is a scientific notation here. Right? So recognizing that, again, you can write that number to standard form by move the decimal left 5 times at 1, 2, 3, 4, 5, and that's why my answer is right here. So recognizing that this is just scientific notation. Again, another one here. So if I have a really big number, notice that my this means 1.25 times 10 to the 12 power. Right? You can write it in scientific notation. That's a really big number here, right? So for the following result, let's rewrite scientific notation in standard form. Let's do it. So this is an output you should see in your calculator. Again, negative 7 tells me I'm going to have a small number. I'll move the decimal to the left 7 times. So for example, I have 2.34 here, meaning that I'm going to move my decimal left 7 times. I'm going to add 60 here. Right. So before the decimal. So again, move left 7 times. So my answer is 0.1230, another 30, and then 234. Now when it's negative 3, again 4.5 move to the left 3 times. You can just move it, count it 1, 2, 3 if needed, just count it, and I filled it in with zeros. So my answer is 0.0045. And when it's positive E4 here, meaning that 10 to the 4 power. So when in standard form, I was 6.11. Positive 4, meaning write 4 times, 2, 4. So I'm going to do 20 here. So my final answer is 61100. Again, positive 5, meaning I move the decimal to the right 5 times. So 5.6 to the right 5 times. So 1, 2, 3, 4, 5. You can literally count them, right? And my final answer is 5, 6 with 4 zeros. Right? So those are final answers. Well, thank you for watching the video. I'll see you next time.